All right, section 4 is about graphing inequalities as well as equalities. Now, equalities just means equations. Inequalities are equations that use the greater than, less than, greater than or equal to, or less than or equal to. So this is basically just about how to graph those ones and plot them on a coordinate grid. So to review, slope, remember, is our rise over run. Take your second, or like a second y value minus your first y value, over first or second x value minus first x value. So if you have 2 points, x1, y1, and x2, y2, again, each of these are separate coordinate points. Take this one minus this one, that's on top. This one minus this one, that's on bottom. That'll help you find your slope, your rise over your run. The x-intercept is where a line crosses the x-axis. It'll always be at some value x and 0. 0 will always be right there. On the flip side of that, the y-intercept is where the y or the line crosses the y-axis. So the first value will always be a 0, and then there will be a y value right here. The standard form of a linear equation is ax plus by equals c. This is not necessarily that great of a form. We don't usually use the standard form because it doesn't tell us a whole lot. We can use that to find other pieces, but we'll normally look for the slope-intercept form. Oops, kind of messed that up. Y equals mx plus b. This is the form you want to put everything in. Circle this, highlight it, underline it. This is how you want your equations to look, because then this m is our slope and this b is our y-intercept. We know where to start from and we know where to go to make our lines or make our graphs. So to graph an inequality, the graph is going to be either a dotted line or a solid line, depending on whether or not there is the or equals to part. If there is an or equals to, it's a solid. If there's not, it's a dotted line. Then you shade the reason that makes the inequality true. And I'll show you what that means. We're going to test a point basically and then go from there. First off, let's go over some examples of just straight up graphing. If we want our x-intercept to be 1, that's going to be right here. We find our x-axis. This is x, this is y. X-intercept equals 1. It's just where this line will hit the x-axis, right at 1, so we'll put a point there. Y-intercept is 3. That's going to be right there. To graph a line then, I'm just going to use our line function. Just connect these 2 points. There we go. Should look something like that. Now, that line isn't as long as we want it to be. I'm going to extend it so it looks like that. There's our line. Goes through those 2 points. If you want, go ahead, put little arrows on the end there so there's a full line. That's all there is to it if they give you an x-intercept and a y-intercept. Y equals negative 5x plus 5. Again, this is already in our mx plus b form. This b value tells you where you start, right here at 5. That is your y-intercept. This m value is the slope. Now, negative 5 is the same as negative 5 over 1. It's saying down 5, right 1. Or, because it is negative, you could have the negative on the bottom piece, 5 over negative 1, which would tell us you're going up 5 and to the left 1. So we're kind of going backwards with that one. We normally think of it as we want to use our positive values down here, because that means we're moving from left to right. This would mean we're moving from right to left, and we don't normally read right to left. We normally read left to right. So this one is telling us down 5, right 1. So from here, we'll go down 5, right 1. There's our other point. Go again, maybe down 5, right 1. Gets us right here. Now again, this tells us the same thing. Left 1, up 5. So if I started here and went left 1, up 5, there's a point. Left 1, up 5, there's a point. So these do mean the same thing. It might be easier to use this one though, because as long as the value on the bottom is positive, it means you're reading from left to right, and that's what you want. Now that we have a couple spots, create our line. You just connect those points. Something like that. Again, put your arrows at the end of it. And that's all there is to it for graphing lines like that. In a case like this, 2x minus 3y equals negative 3. First, we have to put it into that y equals mx plus b form. So we're going to subtract 2x from both sides. minus 2x minus 2x. So it's going to look something like this. This minus stays as a negative, so negative 3y equals that minus 2x is now a negative 2x. It's minus 3 right here. So this is our equation at this point. Now we want to get y all alone, so we're going to divide both sides by negative 3. This whole thing is getting divided by negative 3. When you divide an entire piece by negative 3, it means each of these terms is getting divided by negative 3. So when we do that, everything is going to become, this just becomes y. Negative 2 divided by negative 3, negative over negative is positive, so it's positive 2/3, so 2/3 x. Negative 3 divided by negative 3 becomes a positive 1, so y equals 2/3 x plus 1. Now again, what that tells us, plus 1 means we start here at positive 1 on our y-axis. 2/3 means we go up 2. This is our up and down. This is our going from left to right, and it's positive, which is what we want, which means we're moving to the right, because we always read left to right. So up 2 over 1, 2, 3. Up 2 over 3. Now if we kept going in the other direction, it'd be like down 2 over 3. Down 2 over 3. So those are the points that we would be going through. So then to make our line, just go right through all of them. There we go. And go ahead and put the arrows on there. So we'll find a couple points that it'll go through, connect them with a line. That's all there is to it. Now we've got one that just simply says x is less than negative 4. We treat these first off like x equals negative 4. Treat all of these inequalities as though they're just the equation and go from there. So if x equals negative 4, it's going to be right here, but x is also negative 4 right here, and right here, and right here, and right here, and right here. And all of these spots down here as well. All of these spots, the x value is negative 4. So as you can kind of see, it makes a vertical line. Now is when we go ahead, and because there is a equals to or equals, that's how we decide whether or not we're going to do a dashed line or a solid line. The or equals to means that it is going to be a solid line, so we draw in a solid vertical line extending on forever when we graph this piece. Because it is an inequality, we need to check a spot. We're going to use 0, 0 as our check spot. On this one, our y value is 0 and our x value is 0. So we plug 0, 0 into this equation. X is 0. There isn't a y, but it would say 0 is less than or equal to negative 4. Is this true? Is 0 actually less than or equal to negative 4? No, no it is not, which means this spot is not on the side of the line that should be shaded. The other side should be shaded. So when you shade this, you can simply just take your pencil and shade this area over here and say this is our area that works. That is how you would graph and shade an inequality. Let's see another inequality that actually uses the line. Again, because it has the greater than, we treat it as though it were the equation y equals, negative 1/2 x minus 2. So thinking of it as a y equals that amount, this negative 2 tells us we start right here. This negative 1/2 means we're going down 1, right 2. So down 1, right 2. Down 1, right 2. Down 1, right 2. Or the negative could be applied with this 2, and it would be saying up 1, left 2, which makes sense. From here, going up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2 right here, up 1, left 2 right here, up 1, left 2 right here. So these are all the spots that would be on our line. Now, because this inequality is not the or equals to, it does not have that line underneath it. That line is very important. That tells us that it can either be exactly on this spot, so we'd have a solid line, or it cannot be. It can only get very, very close to that spot, the greater than alone. So we need to make sure we're using a dashed line. So I'm going to use this thing. It'll make a dashed line for us across there. So we've graphed out the line. It was a dashed line, not a solid line. Now we need to check a point like we did before. Again, we're going to check 0, 0. That's a nice, easy spot to check. If 0, 0 doesn't work, you can check any other spot. That is fine. 0, 0 is probably the best and easiest one to pick because you can just plug everything in. So here for 0, 0, it means our x is 0 and our y is 0. So y would be a 0 is greater than negative 1/2 times 0. Anything times 0 is just 0, and then minus 2. So this is our equation. Now, 0 is still on its own, is greater than 0 minus 2 is negative 2. Is 0 actually greater than negative 2? Is that true? Yes, it is. This one actually works out. So this dot is on the side that should be shaded. So you would shade like this. Everything up here, everything above this line is what should be shaded on your graph. And that's really all there is to it. This is how you would graph and shade these areas or these inequalities. Now, we're going to do another one. First off, we need to get it set into a y equals mx plus b form. So, first thing we're going to do is subtract x from both sides. Oops. Back to home. There we go. Delete that. When you subtract x on both sides, it now says negative 5y is less than or equal to negative x minus 15. We just subtracted the x from this side and brought it over here as a negative, so negative 5y stays there. Now to get y alone on both sides, we have to divide by a negative 5. Divide both sides fully by a negative. Now, whenever you multiply or divide by a negative number, you have to flip the entire inequality symbol. So instead of a less than or equal to, it'll now become a greater than or equal to. So this goes away and just leaves the y. Y is now greater than or equal to. Consider this a negative 1. Negative x means negative 1x. Negative 1 divided by negative 5. Negative and negative go away, so it's positive. So it's 1/5. 1/5 x. And negative 15 divided by negative 5. Negative and negative make a positive. 15 over 5, 3. So we are using y is greater than 1/5 x plus 3. This 3 tells us we start here, up at 3. This slopes as we go up 1 over 5, up 1 over 5. It could also mean the same as negative 1 over negative 5, because negative over negative is positive. This would tell us down 1, left 5, which makes sense. Going from here to here, it's down 1, left 5, down 1, left 5. So these are going to be the points that will help us with our line. Because this has the or equals to, that solid line underneath, we know we need to graph it with a solid line looking something like this. And we will finish it off with our arrows at the end there. And again, like before, we're going to test a point 0, 0. We just simply plug it in here and solve it all out. So 0 is greater than or equal to negative, or 1/5 times 0 is just 0. Add 3. So simplifying all that, 0 is greater than or equal to 3. 0 plus 3 is just 3. Is this a true statement? Is 0 actually greater than or equal to 3? No, it is not. So this one is on the wrong side. We should not shade down here. We should be shading everything up here. This is our shaded area. And if this is our shaded area, that's it. That's the end of our shading that inequality. For this inequality, we are using a quadratic equation. Y is greater than 2x squared minus 4x minus 1. Now remember, the trick for graphing inequalities is we want to find our vertex first and then make the table for the points that are around it. How do we find the vertex? Negative b over 2 times a. Now in this case, our b is negative 4, so negative 4 would be a positive 4. Over 2 times a, our a value is 2, so 2 times 2 is 4. 4 over 4 is the same as 1. So this middle point, our vertex, is going to be at where x equals 1. What are three things smaller than 1? We're going to use 0, -1, and -2. That's just going straight downward. What are three things bigger than 1? We would have 2, 3, and 4. So these are the x values for our table. Now we're going to plug each of these in. -2 plugged in here. 2 squared is +4 times 2 is 8. So we have an 8 right here. -2 times 4 is -8. So when we minus a -8, it's like adding. So 8 add 8 is 16, minus 1 would be at 15. Oops, and this showed a 17. This should show a 15. So it would be at -2, 15. As we plug in all of these values, they will become these. I think, yep, this one needs to become a 15 as well. So this would be your table: -2, 15, -1, 5, 0, -1, 1, -3. And remember, this one is the vertex, that's the most important. 2, -1, 3, 5, and 4, 15. Notice that these numbers, -1, 5, and 15, mirror on this side, -1, 5, and 15. So let's start plotting these points. 1, -3. You go over 1, down to -3. This is your vertex, which means right here is your mirror line. When we are at 0, we're down at -1, which means the same thing. When we're at 2, we're at -1. And both of those fit this table. When we are at -1, we're up at 5, which means, again, if we mirror that, when we're at 3, we are at 5. Again, that shows up on the table. -2 goes a little off the chart, up at 15, and so would 4, would go up to 15. So these are the points of our parabola that we'd have. Because this is a greater than and not an or equal to, we would have a dashed line connecting these. So we'd start at the vertex, and we would make a dashed line connecting all of these points that continues on forever. Now again, because this is an inequality, we need to check a point. We're going to check 0, 0 again. All we're doing is just plugging it into this equation and checking to see if it's true. So 0 is greater than 0 squared is 0, times 2 is 0. 4 times 0 is 0, so we have -0, and then -1 at the end. 0 minus 0 minus 1 is -1. Is 0 actually greater than -1? Yes, it is. So our dot is on the correct side that should be shaded. So everything inside of our parabola is what should be shaded. So this is how to graph lines and how to graph inequalities, including our quadratic lines and inequalities. We will go over solutions to systems in our next video.